welcome everyone. We'll be starting in about a minute here. So you're all aware on the screen, we have an email address. If you have any questions during the seminar or at the end for our speakers to answer, please send your questions there. The address is seminarquestions@owp.csus.edu. All right. My clock says 12:01, so we're going to get things rolling here. Greetings, everyone. My name is Christian Carlton. I'm with the Office of Water Programs here at Sac State, and I am filling in for Kevin Murphy as your host today for today's water seminar. From everyone here at OWP, we are really happy to have you all attend today's seminar presentation. As most of you know, OWP is a training and research center here at Sac State with a focus on water quality and water resources. And we annually host 2 fall seminars and 2 spring seminars. This particular year, or this particular semester, this is our only seminar due to some other reasons, constraints, but next semester we have 2 great seminars already lined up. So please watch your email inboxes as we set the dates and get those planned out. I also want to point out to everybody that all of our presentations are recorded and can be accessed via the Office of Water Programs website if you care to revisit and rewatch these. Okay, so today's presentation will be about 45 minutes long, and we should have roughly 10 to 15 minutes left at the end for questions. We'll be going, we may go a little bit beyond 1 p.m. if necessary. Please submit questions by email to the email address currently showing on the screen, which is seminarquestions@owp.csus.edu. We recommend or suggest you take a screenshot so you have that, or we will also be posting it within the chat about every 5-10 minutes if you miss that. Okay, so now let's kick off today's seminar. I'd like to welcome our speakers. I will keep this introduction short because we have a lot of great information for them to share with us. Today is unique. It's the first time we had 3 speakers, so I don't want to cut into their time, and I want to make sure they can present everything they have planned. And our presentation today is going to be about the latest and greatest from the Sacramento River Flood Control Project. Today, we'll be having, as I said, 3 speakers. Dan Tibbetts. I apologize, David. I'm probably going to butcher your last name, but David Pesavento. I think I'm close. And then Sean McNeil. So Dan is a principal engineer with the Sacramento Area Flood Control Agency. David is a supervising engineer with the California Department of Water Resources, and Sean is a senior project manager with the U.S. Army Corps of Engineers. If you want to know more about our speakers, we have their bios posted on the water seminar page on the OWP website. And with that said, I am going to hand this off to Dan Tibbetts to get us started. All right. Take it away, Dan.
Okay, can you see my presentation and can you hear me?
Yes, loud and clear. Looks great. Thank you.
Okay, thanks. Again, I'm Dan Tibbetts. I'm a principal engineer with the Sacramento Area Flood Control Agency. I've been here for about 7 years, and before that, I was with the Army Corps of Engineers. So worked with Sean way back when. I'm going to kind of give some background on the Sacramento River Flood Control Project and get into the need for conveyance improvements, and then basically lead into what David and Sean are going to be talking about. So giving the background needs of their projects, and then they'll talk details about their projects. So what we're looking at on the image here is the Sacramento Weir and bypass in the 1997 flood event. So the weir's in the foreground, heading off towards the top of the screen, and then it flows into the YOLO bypass, which is flowing from north to south, right to left on the screen. So the Sacramento River watershed it's a pretty large watershed. 27,000 square miles of drainage area. It extends 240 miles north to south, 150 miles east to west for width. The major rivers is obviously the Sacramento River is the major river, and then tributaries with the Feather River, the Yuba River, Bear River, and American River. And then elevation extremes, it flows out to the San Francisco Bay, so it goes out to mean sea level, 0, and it goes up to 14,000 feet with Mount Shasta on the far north end of the Sacramento, on the, well, in the state. Now, within this watershed, the low-lying areas, so kind of the wider areas on the watershed map, is the Sacramento Valley. In the particularly low areas of the Sacramento Valley, there's the Sacramento River Flood Control Project. And the red rectangle you see on there, just keep that in mind with when we transition to the next graphic. So the red boundary is basically the map here. I tipped it on its side. So north, in the previous map, north was to the top of the sheet. Now north is pointing to the left. On this map, there's 650 miles of project levee. Project levees refer to a partnership between the federal and state governments of California, going back to 1911 and 1917. The rivers are the Sacramento River, the Feather, the Bear, the American are the main stem rivers. There are various control structures, overflow weirs. Those include Moulton, Colusa, Tisdale, Fremont, and Sacramento weirs. And those all vent flow off into the bypass system. So it's the Butte Basin and Sutter bypass and YOLO bypass. So to get to this flood control system that is depicted on this map was an evolution, trial and error between 1850 or so and 1909. It was trial and error. So people would build levees next to the river, trying to reclaim land for farming, and then they'd have a levee failure, and all of their investment would be lost. So they and others would build more levees and bigger, and think they're safe, and then next big storm comes along and error again, more levee failures. So this continued until 1909, and when it was decided there is no alternative but building a bypass system to vent off flows into the low-lying swamplands and build levee corridors through those swamplands. So this is the same graphic as the previous. I just put it back to north pointing up and then broken in half. So the upstream northern portion of the Sacramento Valley and flood control system is on the left, and then the downstream southerly portion is on the right. Second. Okay, sorry. Okay, key to the bypass system is to vent off flow from the main stem rivers into the large leveed corridors along the historic swamplands in the Sutter and Yolo basins. This starts towards the northern end of the Sacramento Valley near Chico, with flow venting off of the Sacramento River upstream of the project levee and over the Molten and Colusa weirs. And there's images of aerial images of the Molten and Colusa weirs. This flow spills into the Butte Basin and sink, which then drains into the upper end of the Sutter bypass. The Sutter bypass is further fed flow from the Tisdale Weir and bypass from the Feather River. Now I want to talk briefly about the Butte Basin. So the largest reservoirs, they're both water supply and flood control reservoirs, are Shasta and Oroville in the system. They respectively, if I remember correctly, Shasta has 4.5 million acre feet of storage and Oroville is 3.5, if I remember correctly. Butte Basin has 6 million acre feet of flood flow attenuation in it. So it's larger than the largest reservoirs. The attenuation that is happening in this area before it feeds the leveed system, the bypass system downstream. So it's extremely significant from a flood control standpoint. Moving on down the valley, the Sacramento River. Can people see my screen, my mouse when I move it?
Yep.
Okay, this is the Sacramento River here. This is the Sutter bypass. So the Sacramento River kind of transitions from a westerly side of the valley to an easterly side of the valley and basically intercepts the Sutter bypass. So there needed to be a mechanism for transitioning the bypass from one side of the river to the other, and that takes the shape of Fremont Weir, which is about 30 miles north of Sacramento here. It's a 2-mile long structure, just over 10,000 feet, and just an overflow weir. And it basically locks the Sacramento River from into the course that it historically had, and thereby keeping all the infrastructure that's dependent upon that in place. The bottom picture on the left is a picture taken from a plane or helicopter, I think it was, during the '97 flood event. The weir is right here, and then the Sutter bypass is heading, well, going upstream in the distance with the Sutter Buttes here, and then the Yolo bypass is going towards the bottom of the picture. So it's a pretty it's not an overflow weir like the other weirs in the system are. It's a crossover feature. Pretty interesting how it works. And then heading on downstream, there's the Sacramento Weir and bypass. Contributes American River flow into the Yolo bypass. And then the Yolo bypass, a couple of photographs at I-5, so just west of the Sacramento airport, and then down at Lisbon, about 5 or 10 miles south of town here. About 50 miles further downstream, the Yolo bypass and the Sacramento River come back together near Rio Vista. This flow combines and then continues downstream into the Sassoon Bay, the San Pablo Bay, the San Francisco Bay, and out to the Pacific Ocean. During significant flood events, such as a 50-year event and greater, approximately 80% of the flood conveyance is happening in the bypass system, with only 20% happening in the main stem rivers, just to put things in perspective of the importance of the bypass system. So the bypass system was designed to convey flow experienced in the 1907 and 1909 flood events. At the time, it was believed that these were the most extreme floods that reasonably would ever be experienced on the Sacramento River system. Design thereafter began around conveying these flows and volumes of water through the Sacramento Valley. Construction of the flood control system was completed in the mid-1950s. Coincidentally, at the same time, we had a new flood of record in 1955. So this 1955 flood was larger than the 1907 and 1909 flood events throughout the system. It became apparent that the flood system might have been under design with regards to the flow rates that it was designed to convey. This conclusion was validated with the floods of 1964, 1986, and 1997, with 1986 being the current flood of record. Therefore, if the goal is to convey through the valley the highest rate of flow that could be experienced, then there is a need to enhance the conveyance capacity of the bypass system. The state of California's Department of Water Resources, as part of their Central Valley Flood Protection Plan in 2012 and amended in 2017 and 2022, recognized this need and included setting back the east levee of the Yola bypass and the north levee of the Sacramento bypass in the lower Elkhorn Basin. DWR got the lower Elkhorn Basin levee setback project to construction and are now nearing completion. David Pesavento with DWR will explain the details of this project momentarily. The U.S. Army Corps of Engineers, as part of their American River Common Features General Reevaluation Report, also recognized the need to set back the north levee of the Sacramento bypass and expand the Sacramento Weir. They were successful at obtaining congressional authorization for this work as part of the Water Resource Development Act of 2016. The Corps got the Sacramento Weir project through design and have just initiated construction. Sean McNeil with the Corps, will explain details of this project in a few minutes. And then final graphic here. This is an aerial photograph of the 97 flood event. The Yola bypass is the big water body flowing downstream from right to left. The Sacramento bypass is flowing from the Sacramento River into the Yola bypass. And the green lines on the map depict existing project levees. I'm going to say existing or historic project levees, because David, as part of his project, is in the process of dismantling a couple of these green lines with the expanded bypasses. And then you see the expanded bypass, the one adjacent to the Sacramento bypass. That's the widened Sacramento Weir or Sacramento bypass that David is working on. In the a little above that, adjacent to the Yola bypass, the green line is being replaced by the orange line with the setback levee that David's constructing there. So ultimately, and the Yola bypass extends off to the right of the screen some. The aerial image I had didn't go all the way up to the top of the setback levee, but there's 2 miles on Sacramento bypass of setback levee and 5 miles on Yola bypass that David is expanding. So with that, I'd like to hand it off to David to talk about the Levels project. And thank you for your time.
Thank you, Dan. My name is David Pesavento, and I am an engineer with the California Department of Water Resources. Let me get my screen sharing. Can everyone see that okay?
No, it's still
No.
showing you.
Okay, give me one moment. So sorry.
There we go. That looks good.
Great. So thank you very much, Dan. So I've been working on the Lower Elkhorn Basin Levee Setback Project, or levels. Being from the government, we love our acronyms, since 2015. And I did graduate from Sacramento State, so thank you very much for this opportunity to speak with you. Going into just briefly emphasizing a couple things that Dan was talking about. We've gone through since Katrina, we've gone through different phases of improving the flood control system. We have been focusing in the recent years on what we call the early implementation program. That's where we've been working with locals and with the Army Corps of Engineers to enhance specific levees throughout the system. The Levels project is the first time that the Department of Water Resources has initiated this work and led this. We are looking at what we call a system-wide project, where instead of looking at one specific benefit, one specific levee that protects one basin, we're enhancing the system, as Dan was describing. One of the quick things that I would like to emphasize is a phenomenon within the system. The images that Dan was showing, the American River does put more water into the Sacramento River, and during high water events, that water actually flows from south to north and through the Sacramento bypass to be able to get out into the Yolo bypass. The Yolo bypass, as Dan was describing, is a low point in the system, so we're mimicking that natural process. We talk about multi-benefit projects, we talk about engineering with nature. All that just means that we're working with that natural process to mimic the way that the water has been flowing since before we were involved and started engineering things. So within the regional context, I also manage the system-wide flood risk reduction project. So there's a lot of different projects that we're looking at right now that are either being considered or underway throughout the Yolo bypass. These are some of them. And the discussion today, of course, is on the Lower Elkhorn Basin Levee Setback Project, which is located over in this area, a little bit further towards the north. This project is about a 7-mile long levee setback. We are setting back the levee, and that means basically moving the levee or creating a new levee about 1,500 feet away from the existing levee, which creates that additional capacity. About 1,500 square linear feet from the existing levee along the Yolo bypass, and then approximately doubling the size of the Sacramento bypass. Along with that, we are doing a lot of ecosystem improvements, and we are focused on doing some ag improvements and contributing towards agriculture in the region. The levee is made out of native soils, and we'll talk a little bit about that. The native soils in this area are a fat clay, which is generally not used for levees. Because of that, then we have a larger levee prism, 4-to-1 side slopes, and a 28-foot wide crown. The project is about 5 million cubic yards of soil that is being used to construct the levee. Moving on a little bit more, so you can see here in green, the new setback levee and that existing levee that is, as Dan said, now being removed. There's some other components that we've been working on. This project, and this is a theme that you'll hear throughout today, I hope, is really successful because of all the partnerships. DWR has worked with the Army Corps of Engineers and SAFCA throughout this project to make sure that it's successful. There's various components like the pump station and the Bright landfill relocation that were led by SAFCA in partnership with DWR. So along with the levee, we're making additional enhancements to the interior drainage, redoing some of the drainage conveyance facilities, and we combined, working with SAFCA, the historic 3 different reclamation districts into one, which is going to create some efficiencies in the local administration of the system in that basin. So quickly go through a few different photos. Who doesn't like some good construction photos? And one of the things that you'll see here is on the right side, one of our team created this really cool graphic that shows the perspective where this picture is being taken from. I mentioned before that the levees be constructed out of native material, a fat clay. This requires a lot of processing by the contractor. The contractor on this project on levels is Forgin, and you can see some different equipment out here. For example, this equipment here looks like something that you would more typically find out on a farm and in agriculture. So they do have to process this material quite a bit, wetting it, mixing it, scooping it up with the scrapers, and then placing it and compacting it. Few other quick photos. The existing Sacramento bypass levee down here, we placed a temporary embankment for consolidation. And then you can see the setback levee going along here with the foundation being excavated and prepared for the levee. Another view, you can see the Yola bypass here. This is looking south. This is an example of some of the interior drainage features that SAFCA partnered with DWR to help us enhance. The levee in this photo, you can see some of the seepage berms that we're putting out here, and then the different color on the levee is due to erosion control measures. This is a view of the corrective action management unit for the Bright landfill, and Dan can answer more questions about all that, and the new pump station that we're constructing. The pump station pumps all the drainage from the interior of the basin and then out into the bypass system. Another view of the pump station. You can see the levee in the background here and the expanded bypass. You can also see in this view some of these borrow pits. They're full of water in this area. The ground elevation is very low. In this part of the basin, the ground is about 12 feet above mean sea level. Pretty low, and it will fill up with water. But that is where the material was excavated from, and then, pardon the term, but flopped over then to construct the levee. What we're currently doing now is flopping over the existing levee, degrading that, and putting it back into the borrow pits. So I mentioned before, this is a really great photo. I love seeing this. You can see downtown Sacramento in the background, another perspective of what you were seeing earlier, the historic Sacramento Weir in the foreground, and then the existing levee. Like I said before, we placed embankment here for consolidation, and then this embankment was removed, and then currently the levee is tied into the existing levee on a permanent basis. One of the features of this project that I'd like to take a few minutes to speak about is the tied concrete block mat. Briefly, when the bypass is full, generally we get storms that are coming through this area from the south and west, and so wind will go across this. You can end up with what we call a wind fetch of up to tens of miles long with strong winds that we experience during storms. That can whip up significant waves that will crash against that levee, and if the levee is not adequately protected, it can cause erosion on the levee and possibly even lead to a levee failure. So we are using this tied concrete block mat to place on that surface of the levee to help attenuate some of that velocity and potential for erosion. The tied concrete block mat is actually not the primary level of protection. We are placing soil on top of the tied concrete block mat and then growing native grasses on top of that. Native grasses have a deeper root system that will penetrate deeper and provide additional erosion protection. So this is an example out in the delta of what can occur during those storms. You can get waves that are crashing up against these levees. This is just an example. In this specific instance, it was taking large rocks and literally throwing it up and over the levee. It's very strong forces that we're looking at. And no, I do not recommend anyone actually drive on top of a levee when this is occurring. That's not particularly safe. Typically, what's done is to use large rock. We call it rock slope protection. And that is placed along the surface of the levee, but it's more expensive. It's not as environmentally friendly for wildlife, and it's a whole lot more difficult to maintain. Instead, on this project, we're going with this tied concrete block mat and then using those grasses to fill in. The native grasses are also foraging habitat for Swainson hawk. This is a close-up view of the tied concrete block mat. You can see that they're just little domes of concrete that are cast into a geotextile grid. Then that grid is placed on top of the slope. And then after a little bit of time, the grass can grow in, and it's indistinguishable from a normal levee with grass on it. So again, just demonstrating that deep root network that penetrates deeper into the levee than some of the invasive species. This, like I said, this has not been done before on the state federal levee system. And we invested in doing some trials early in the project. We went out there and we placed some of these tied concrete block mats and put soil over it and did various methods to establish grasses on top of it. We learned from that, we refined our approach, and are now implementing what we believe to be the most significant or the most likely to succeed method. This is approximately 7 miles of this product, not a small investment, and we wanted to ensure that it was going to be successful. The actual casting of the blocks is, I think, a fascinating process. You can see here that they will back up a concrete truck to this special apparatus. If you look very closely, you can kind of see this casting mechanism looks like a big ravioli roller, and does the casting of all that concrete onto that geotextile fabric that you can see being paid out into this casting machine, and then it leaves behind this strip that can then be cut up and rolled up and placed onto the levee. Another view of that giant ravioli roller, if you will, and that casting process. And then this is the tied concrete block mats placed onto the levee. They extend approximately 60 feet down that levee slope on the water side. We did start construction of this project in August 2020 during the pandemic, which presented some additional challenges, but we did get it successfully into construction. We have now actually completed, as of now, completed all placement of the levee embankment, have started working on degrading the existing levee, putting that material back into the burrow. The tied concrete block mats are almost completely placed, soil being spread on top of that, and plantings will be continuing on top of that for this winter. So summer, we breached the levee, we're moving forward with it, and we will be ready for flow this winter. What that means for everyone is that there will be additional capacity in the bypass system for this winter. The project will continue for 5 years with an establishment period to ensure that all the plantings that we're doing as a part of the project are completed and will be successful. Finally, again, I talked about partnership. This is a list of some of the different entities that we've enjoyed partnership with on this project. This truly has been a group effort. Central Valley Flood Protection Board, Yochadihi Wintu Nation, California Department of Fish and Wildlife, Army Corps of Engineers, West Sacramento Area Flood Control Agency, Yolo County, the contractors, and of course, Sacramento Area Flood Control has been a tremendous partner in this project. So look, thank you very much for your time. At this time, I'd like to pass it off to Sean. Thank you.
Hey, thanks. Sean McNeil, Army Corps of Engineers, Senior Project Manager for the Sacramento Weir Widening Project. I'm about to share my screen here. to get my presentation up, and then we'll begin. And then if you guys can confirm that you can see my screen, we'll go ahead.
You're good. Perfect.
Awesome. So, my background's in environmental engineering. I'm a project manager in $73 million construction project. I'm about 15 years into my career. And I think if you would have talked to me back when I was a student, I would be super pleased that that's where I ended up 15 years from the day I graduated, in times when Katrina happened when I was a senior in college, right? And I wanted to impact projects like this. That's awesome and amazing to have the responsibility to help lead and coordinate a design and construction team. We have and partners. I mean, we have over 300 people that have touched this project. So it's been an absolutely cool thing to be a part of. And if you don't know a lot about the Army Corps of Engineers, we do a lot of flood control related work, amongst other things like military construction, remediation of munitions and contaminated plumes. And so it's one of our really cool missions to do this. And we in the Sacramento district are the largest district in the Corps of Engineers right now. The most money coming through that we have to execute in the area. And we have 20 years worth of work, 30 years worth of work in this area in flood control with the Lower San Joaquin and some other projects coming. So it's really exciting time to be a part of the Corps of Engineers and the work that we get to touch. And if you're going to be working in the Sacramento area, there's a lot of flood control related work, no matter where you sit, whether it's on the government side, consultant, really cool things coming through the pipe. So like David said, we have a lot of collaboration. As a federal government, I don't just get to come in and do everything that I think should be done. We get parameters placed on us from Congress. We get the local and state parameters placed in. We have regulatory agencies who give us the BIOPS and biological opinions and other parameters that we need to also hit the mark on while also building a project per the request. So huge team, many disciplines. And I'll say being a project manager can get intimidating, but I'll tell you, if you've never thought about project management as a part of your career, you get to liaison between so many disciplines. And so being an effective communicator, as well as knowing who's doing what and connecting the dots between two different disciplines, is an art and a science in itself, and very valuable to the success of projects. We've already gone through where the Sacramento Weir is in the system, so I won't repeat this information so we save time for questions. Let's go through the major features of the Sacramento Weir project. It's $173 million construction project awarded this year. We started it at the end of July. So we have a road bridge that we have to build. So we're taking down the Sac Bank levee demolition at the end of the project. We have to build a road bridge over this area so we can pass water under it. So the current Old River Road is on top of a levee. And so we have to transition traffic off of that levee so we can demo it and onto this road bridge. So that's one major feature. The lower Elkhorn baseline levee setback, they're doing most of the bypass widening, but we're going to finish out the bypass widening and connect it from the tie-in levee all the way to Old River Road. And you can see on the existing Sacramento bypass side, it's about 1,800 feet across. We're going another 1,500 feet. So we're, in a sense, almost double the capacity of water to go downrange, which is really cool. Also, as part of this project, when I mentioned the fish biological opinion, fish stranding is an area that problem area in the bypass. After flood events, fish will strand in different depressions, sometimes against the needle gates of the existing weir. Juveniles get through the slats and into the stilling basin. So we've been asked to make sure the fish stranding is minimized to the extent possible. So from right to left, we slope the entire bypass towards that fish passage channel that's in brown that goes out to the yellow bypass. But we're also installing a fish passage control structure that's going to allow fish to swim towards the Sacramento River and out on their own into the Sacramento River versus having to be pumped out by the Central Valley California Department of Fish and Wildlife. So we've been asked to do a lot, but that's part of the job, is to execute big missions. And we just, like any engineering solution, we break it down into small parts and we start solving it one by one until we get the whole collective whole done. Here's some stats for you on the magnitude. I'm not going to go in this for time, but just to give you a sense of how much distance or quantity is involved in each of the features. This is an isometric of the road bridge in Weir. This is a passive weir. The existing Sacramento Weir is the last operated weir where they have to pull a pin that allows the needle gate weir to open, flow downstream on these metal chains, and then they have to bring them back in by fishing them with like a hook and a pole and resetting them to put them back. And so we're going to allow water to flow over at a certain elevation naturally with no operator input to go over that, which is really nice for the agency like DWR, so they can put manpower during emergencies elsewhere. But also this will work in conjunction with the existing weir. So still, when the flow hits a certain elevation or the water level at I Street Bridge, the existing Sacramento Weir will still operate if the water level is high enough after ours is already spilling. But a really cool feature, and we're glad to put another passive feature into the system. Here's just showing kind of our stilling basin and some of the exit slab and riprap to prevent that scour. There is kind of a drop here, so we want to make sure in the initial water overflow situation that we take out that energy to make sure we don't get scour as the water starts to fill the Sacramento bypass. All right, and then we have the North Levee setback. We are relocating a County Road 126. It's on the existing North Levee. It's already been demolished for the most part, and we're putting it on the new North Levee. And in that sense, we have to take a patrol road and kind of bring a county road on the levee to connect at the elevation of Old River Road. So you can kind of see that it's a little higher than the levee, and that's just to get to the Old River Road height at the end, or over our levee, and then we'll be on the land side. All right, and then the fish passage structure. So we're a unique project where we have a couple ESA listed species, salmonids being a big thing, and then green sturgeon being our largest fish in the system that we have to account for. There's no design guides out there for green sturgeon. There's a lot of design guides for salmon. So we had a very diverse team of the West Coast region, regulatory, AE designers. We had people from DWR, UC Davis, Army Corps from all the way from Sacramento all the way up to Washington State meet and talk, and 2 years of meetings to get to the approach to create a flow velocity that the fish can swim through, where it's not so fast that they can't make it and lose some of their eggs, for the females coming through, but also not so slow where they don't even come this way. So they need some velocity signature to swim into to go that direction. And so on the bottom side, you'll see a fish ladder, a traditional fish ladder for the most part that the fish can go through. And then at different water elevations on the top, you have an open channel where the larger fish can go down because they like to hunker down a little bit lower and they can swim through the system. So we're really excited to see this. We've started testing this, the gate setup at UC Davis. So we're getting an inclination with some white sturgeon of how this is going to operate, but we definitely really want to see it after we've built it and go to operate it. Here's some more quantities for the fish passage feature. Again, I won't go into it due to time, but you have some of the, it's a 30-foot tall, 150-foot long feature, roughly in the magnitude of like 40 to 60 million range, depending on how you, some of the costs are shared between other features. But it's a very big feature, but a necessary thing, because when we do civil works flood projects, we still got to think about the environment and how we're impacting fish and other species. So for the environmental summary, for the most part, we're self-mitigating on our project, but we also had some velve, some Valley elderberry, longhorn beetle. We bought some credits to satisfy that. We're doing a lot of fish. The fish passage feature itself is kind of a mitigation for the fish stranding in the bypass, but also we got some mitigation credit for connecting to the existing Sacramento Weir stilling basin and connecting. We're going to connect that to our fish passage channel. So those juveniles that get into the system through the slats will get into a channel that goes out to the Yellow Bypass and to the Thule Canal, which will prevent us from having to go suction them out there and give them a better survivability chance. We're in a GGS area, but it's not designated critical habitat. So we're just looking out for them right now. But we will provide better habitat on after our project's done. And then air quality, the Sacramento Weir is not by itself. It's a larger project. And so we triggered the general conformity rules, and we're using a lot, and we require tier 4 equipment for most of our stuff. You have to get permission to use under, and we're using the best that the industry has to offer to minimize our air pollutants. And also we have dust control measures and all the other BMPs that you would typically see on a site to help reduce environmental impacts. That's all I had to share. I will pass it back to the moderator to start answering questions.
Thank you very much, Sean. I really actually appreciate your comments about communication. I talked to all of our student interns about that, and they all give me the same look of, why are you talking to me about this? I'm here to learn about engineering and water. And it's good to hear somebody reiterating that. So thank you very much. All right, so let's hear. We're doing all right. We have plenty of time for questions. We have a few starting to come in, but please send your questions to what is our email address, which is seminarquestions@owp.csus.edu. I am going to kick a question off though here for you guys. If you could just tell us perhaps like one of the biggest challenges you guys have run into working on such a large, diverse, multi-agency project, and how you've tackled and dealt with those solutions. Just so some of our students can kind of get an idea of, we're in the business of solving problems, and there isn't any problem that you can't solve, really. Any thoughts?
I guess I could start. With a large project like this, you're going to hit challenges. Like, it's a known thing. There's no way you can set up a project like this and not have challenges. It's just really how you overcome and you get through them. Some of the challenges, you have the federal government designing this. We chose to self-perform and have an AE design. And then we have partners who also want a hand in the design. So I think there were times where everybody has a different idea of how they see this project going forward. And when we started the project, the planning phase didn't fully define what we were going to design and build. So the first challenge we had to get through was really having a design charrette and partnering with everybody in the room to get to the design solution you see today. And that was really instrumental in getting the design team focused to exactly what they need to do, or to go find solutions to the problems and identify those extra parameters that might have not been well defined in the beginning. That's my addition to that.
And I'll continue a little bit. I think that kind of going back to communication and coordination with people and partnership. One of the challenges working for government is there's different restrictions. From what I've learned, it being involved, there's restrictions with the federal government, there's restrictions with state government, there's restrictions with local government. But when you can come together and work towards each other's strengths, then that helps the project be more successful. An example is with the interior drainage that I was talking about for levels. We designed levels in-house for DWR. We did have consultants helping us, but it was designed in-house. And we started the design in 2015, and then 2017 happened. And with Oroville, our department became very busy, and we weren't able to complete some components. So again, working with our partners, SAFCA was able to take on some of the interior drainage designs and complete that in time so that we could be successful with the project.
And I'm going to hammer on the communication point. Christian, I couldn't agree with you more. I'm going to say that, okay, I'm more than 30 years into my career, and I'm going to say that 90% of the engineer's job is communication. It is that important. It's much more than just doing the calculations that you're learning in school. Communication is key. These projects, okay, so there are a lot of regulatory agencies that we have to work with to get big projects like this. At the state level, there's the California Department of Fish and Wildlife. There is the State Water Resource Control Board. The federal level, there's the resource agencies, the U.S. Fish and Wildlife Service and the National Marine Fisheries Service. Everybody has concerns, and to get projects like this through, we need to work closely with them to mitigate their concerns. So back to the communications as the major job of the engineer.
I love it. That's great. Thank you, all three of you. All right, so let's, we've got questions rolling in. Again, for everybody, please send your questions in to seminarquestions@owp.csus.edu. And you can also find it in the chat. First question up for you guys. Let's hear. For future use of concrete tile mats on the side of levees, would you consider some integration of other native flowering plants to support pollinators?
That's a great point. There are some different types of plants that we're considering. There's different uses for different plants. So for example, there are forbs that are more helpful for species like monarch butterflies. And what we did is we worked very carefully with GEI consultants to help select what that planting palette is. It's a mix between different grasses and some flowering things. But you also have to look at, pardon me, you have to look at what the purpose of this structure is. And you have to make sure that any plants are going to be compatible with that. This needs to be able to be mowed, which is another advantage to using the Tide concrete block mat. And so you're going to have a limited flowering window potentially.
Good point. That's very interesting. Things you don't really think about as the casual observer. So another question, generally speaking, is seepage beneath the levees a concern?
I'll start that, and then Sean, I think you're dealing with some different challenges. The soil out in this basin is different. Closer to the river, you have more sandy soil. Closer to the bypass, you have more clay soil. There is seepage through and underneath the levee. You do have to do explorations. We did extensive explorations to understand where that risk is. And then there are seepage berms that were placed of various widths to mitigate the seepage concern. But Sean?
Yeah, I mean, you really covered it. So usually we have more seepage in your historical levees that are already out there because they were built with clamshells and, you know, whatever was next to it was placed there, right? We're constructing this from scratch. So we get to call out the type of soil, the slope, what we call the levee prism, right? And so I think we're a little more stringent on my side towards the river, but we went 4-to-1 slopes on the majority of the levees because we had that soil available, and so we didn't have to import soil, which reduced our impacts. But typically, you know, we do steeper slopes if we have better soils. But this case, we went 4-to-1, and so, but all the and there's stability berms and different things that help prevent seepage through and under. So, great question.
All right. Oh, this is a good question. From a law student, how can lawyers work better with engineers to complete these kinds of projects?
I could start, I guess. I deal with lawyers all the time on my projects. You know, knowing the root laws for one, right? So you start with like Clean Water Acts and different things, but all the way to how do we get to yes on doing what's good for the public good within the laws and parameters that we have. The lawyers are definitely instrumental because sometimes some of our biggest frictions is how each agency does work differently. Like David's got different rules than I got for procurement, from how we get our money, colors of money. Same with SAFCA. They have different arms and mechanisms. And so sometimes we have lawyers from each group in a meeting and we all step out. We're like, you guys just hash that out and send us back your final response because you know it's very complicated, and we definitely appreciate having legal advice through the whole project.
I'll continue briefly. I think it goes back to this communication, and guess what? That's going to be a theme. To be successful with these projects really requires a team of different disciplines. You cannot be successful by just having a team of engineers. You have to have lawyers. You have to have environmental scientists. You have to be able to meet and talk about things, different perspectives, and be open to those different perspectives and problem solve things together. Everyone brings different skill sets and different perspectives, and that's really important.
And I'll just hammer on the communications theme again. Lawyers, every agency that I mentioned before, they have their own lawyers, so they're coming to the table too. So it boils down to communication.
That's just something you don't really think about in the technical field when you're in school, is that you're going to have to work with lawyers. So I think that's a great question, and being able to work closely with them, all these people with different backgrounds, it's really important.
And it's not just intermittent working with attorneys. It's pretty darn constant. It's pretty darn constant working with real estate specialists and an environmental biologist, cultural people, engineers, various disciplines, electrical, mechanical, civil, geotechnical, etc. So working with people is key to getting these projects through, therefore communication.
And just to take it one step further, you know, diversity and inclusion. So you got the diversity of disciplines, but you also, those people are sitting at the table. You got to draw them out if they're quiet or if you're quiet, right? And you got to be able to put your piece of the pie's input into the team design so that we get the necessary real estate. We have the environmental stuff figured out. You know, if somebody might not be an expert in your field and they're commenting on it, allow them to say that even if it's wrong, and take it and give it back to why you can't do it that way, and go, don't be offended that they're talking in your lane, right? We want all the, because when you're putting this much money and effort forward, you want to make sure you try to remove any flaws you have in your design out before you get to construction, where the money really starts to stack up if you have errors or flaws in your design.
All excellent points. Let's see here. This is interesting, a good question. Paraphrasing here, within this project, have you guys looked at or considered returning some of the floodplains back to wetlands as opposed to using the levees?
Oh, I'll take that one if that's okay. Absolutely. But all these things are complex. You have different players with different perspectives again, and you need to be able to sit down and talk with them. In this particular instance, especially for levels, you have people that are interested in maintaining agriculture. The existing basin before we started this project was agriculture. That is local income and income to the county, other jurisdictions, and there's a balance. There always needs to be this balance between all these different benefits that you can potentially get out of the project. There's some areas where we're putting in different types of ecosystem value and some areas where there's agriculture. But the really powerful things are where you can do things like rice or row crops that can benefit environmental species, fish, birds, as well as still contributing to agriculture.
That's a great answer. That balance is such a tough one to strike with everybody involved. So we do appreciate you guys doing your best to strike that balance. Let's hear another question for you guys. Oh, did you consider using a woodland buffer like was used along the Feather River to protect the levees from waves?
We have, and we may still be able to implement something like that in the future. One of the things I didn't talk about with the Levels project is we were on a very compressed timeline. We had funding that we were given that we had to commit by a certain time, or we would potentially lose it. So there's some things that we are still looking forward to implementing in the future, but we weren't able to fully implement. Doing a buffer along the Tule Canal is something that we are still interested in pursuing in the future.
Right. That's another interesting situation where you have funding that all of a sudden you have to spend. And the whole funding mechanism is just, it's almost a whole nother class that you have to learn. That's a great question, a great answer. All right. Oh, we're just running a little over past 2 o'clock. I think I have one more question here that came in. Nope, actually I already asked that question. All right, I think we hit them all. Some of them overlapped, so I didn't answer everybody's word for word, but I think just about all the questions got answered, asked and answered. So with that, I would really like to thank everybody for attending. I would like to thank our speakers. We really appreciate it. And I hope everybody has a great weekend and hope to see you back at our next seminar. Thank you.
Thank you all.
Bye.
Thanks.
Thank you.